right? Because acceleration is vector quantity, mass is itself is a scalar. हेलो स्टूडेंट्स, कैसे हैं आप लोग? तो आज हम लोग देखने वाले हैं फोर्स, राइट? फोर्स के बारे में बात करेंगे आज हम लोग। बेसिक नॉलेज जो फोर्स में रिक्वायर्ड होता है, ठीक है, फोर्स को समझने के लिए, उसको आज हम लोग देखेंगे, है ना? चलिए बात करते हैं, बहुत ही बेसिक से शुरू करते हैं, है ना? फर्स्ट क्या है जो हम लोग बचपन में पढ़ते थे, आज भी वो ट्रू है। फोर्स क्या है? डिफिनेशन, पुल एंड पुश इज कॉल्ड फोर्स। पुल एंड पुश, राइट? पुल एंड पुश इज कॉल्ड फोर्स। ये बेसिक बच्चों वाला डिफिनेशन है ना? यहां से शुरू करते हैं। देन जो हम लोग के लिए डेफिनेशन है वो है फोर्स इज रेट ऑफ चेंज ऑफ मोमेंटम। फोर्स क्या होता है? बेसिकली रेट ऑफ चेंज ऑफ मोमेंटम, है ना? यहां से हम लोग डिफाइन करते हैं फोर्स को, रेट ऑफ चेंज ऑफ मोमेंटम, राइट? तो रेट ऑफ चेंज ऑफ मोमेंटम, इसको हम लोग क्या लिख सकते हैं? इसको हम लोग लिख सकते हैं m dv अपॉन dt प्लस v dm अपॉन dt, राइट? रेट ऑफ चेंज है तो m dv अपॉन dt प्लस v dm अपॉन dt। ये कब ट्रू होगा? जब मास कांस्टेंट है, राइट? m कांस्टेंट। जब मास वेरिंग होगा तो हम लोग ये वाला फॉर्मूला यूज करेंगे, राइट? यहां पे क्या है? मास वेरिंग है, राइट? दैट इज मास रेट के टर्म में अगर एक्सप्रेशन होगा मास रेट के टर्म में, जैसे रॉकेट में क्या होता है? वेलोसिटी कांस्टेंट वेलोसिटी से जाते रहते हैं, फ्यूल कंज्यूम होता है, तो रॉकेट का मास जो है कम होता जाता है, राइट? रॉकेट का मास कम होता जाता है ना? तो ये एक डेफिनेशन है, बेसिक डेफिनेशन है फोर्स का, राइट? थर्ड हम लोग देखेंगे, फोर्स जो होता है F एक्सटर्नल इज इक्वल टू मास इनटू acceleration of center of mass, right? F external is mass into acceleration of center of mass। जैसे मान लीजिए अगर कोई बॉडी है, राइट, दूसरे बॉडी से अटैच है, लेट्स कॉल इट m1, लेट्स कॉल इट m2, राइट? लेट्स कॉल इट m1, लेट्स कॉल इट m2। अब यहां पे अगर आप फोर्स लगा रहे हैं, राइट, यहां पे अगर आप फोर्स लगा रहे हैं F, तो जो हम लोग एक्सीलरेशन लिखते हैं, एक्सीलरेशन क्या लिखते हैं हम लोग? F अपॉन m1 प्लस m2, राइट? F अपॉन m1 प्लस m2। तो ये जो F अपॉन m1 प्लस m2 है, ये क्या है? ये पूरे सिस्टम का एक्सीलरेशन है, राइट? पूरे सिस्टम का एक्सीलरेशन है, which is the acceleration of, we can call acceleration of center of mass, right? We can call it acceleration of center of mass, right? ये भी ट्रू होता है ना? ये फोर्स क्या है? फोर्स इज अ वेक्टर क्वांटिटी, राइट? फोर्स इज अ वेक्टर क्वांटिटी। ओके, बिफोर गोइंग टू द वेक्टर क्वांटिटी, वी कैन कॉल दिस फोर्स एज dp upon dt as mentioned here, right? D small p, that is momentum, upon dt, right? So now we can write, so dp is equal to what? dp is equal to f dt, right? dp is equal to f dt. This both is very important, right? This one is impulse and this is the slope. This represents slope in PT graph, right? That is momentum time graph, right? So force in a graph can be defined as, so if the graph is momentum time graph, right? And its rate is changing like this, right? Its rate is changing like this. So we can define the force as slope at a certain point. So this will give you, so tan theta tan theta, which is equal to dp upon dt, will be equal to F, force, right? So here we can define the force as the slope in PT graph, right? Now force in vector form. So force in vector form, how we can write, that is mass into acceleration vector, or we can write, suppose this is F1, right? This is F2. So F resultant, we can write the vector, we can do the vector addition. We have to follow the vector addition, because if you treat force is a vector quantity, right? Because acceleration is vector quantity, mass is itself is a scalar, right? So here we will follow the vector addition, either in terms of this, that is this form we called as R theta form, or we can write force as xi plus yj plus zk in terms of zk, that is called Cartesian form, right? So that is called Cartesian form. Let's solve some questions, so you'll get to know more about this, right? Basically we'll do the questions, we'll see the question type. A block of metal weighs 5 kg, right? A block of metal weighs 5 kg is resting on a frictionless plane. It is struck by a jet releasing water at the rate of 2 kg per second and with a speed of 10 meter per second. Initial acceleration of the block is, right? So initial acceleration of the block is, let's solve. We know F is equal to V into dm upon dt, right? What's happening here? Here, this is smooth surface, right? A block is kept on this smooth surface of mass m. Let's call it m. M given as 5 kg, right? Now jet, water jet is there, right? So water jet is spreading jet on this block, right? So water jet is spreading jet on this block at the rate of 2 kg per second. That means 2 kg per second. That is m dot. M dot, we can write it as m dot, right? 2 kg per second. M dot means dm upon dt, right? So m dot is basically dm upon dt, right? Now speed of the jet, right? So velocity of the jet is how much? Velocity is 10 meter per second, right? So velocity here is 10 meter per second, right? So jet velocity is given. What will happen? This jet will strike, right? Its momentum will change, and that change in momentum will impart force, right? So that means there will be force on this block, right? There will be force on this block. So how we will write force? Force will be basically equal to V into dm by dt, right? V into dm by dt. So here V is 10, dm by dt rate change is 2, right? So you will get 20 Newton. So unit of force is 20 Newton. Basically Newton is kg meter per second square, right? Or we can write in terms of dimension as mlt minus 2, right? So this is the force here, but they have asked you the acceleration of the block, right? So acceleration means here acceleration will be F upon m, right? So it will be 20 upon 5, right? So it will be how much? It is coming as, right? So it is coming as 4 meter per second square, right? So it is coming as 4 meter per second square. So is there any answer? Is there? No. None of these. Right? Block weight is 5 kg. Right? So it is coming as 4 meter per second square. So acceleration is 4 meter per second square. Right? Okay. So now we'll see the next question. 3 forces. This is based on the, let's see how we can solve it. Right. So the question is 3 forces starts acting simultaneously on a particle moving with velocity v. Right? So here the three forces, these forces are represented in magnitude and direction by the sides of the triangle in figure. Right? So the sides of the triangle representing the magnitude and direction of the force. Right? The particle will now have move with velocity. So velocity of the particle will, right? See here, if we call this as F1, right? So this is F1. If we call this as F2, if we call this as F3, right? So the resultant of F1, F2 is how much? Resultant of F1 and F3, right? So resultant of F1 and F3, how we will find out? We will shift this to this side. So this will give you the resultant, right? So if we say the resultant of F1 and F3, can we write it like this? So the resultant of F1 and F3 is like this, right? So this is F resultant, 1, 3, right? So the resultant of F1 and F3. Now look at this, F2, right? So F2 is what? F2 is opposite to the F resultant, right? And they said that represents the magnitude and direction by the sides of the triangle. So it represents the magnitude and direction of the sides of the triangle, right? And we know triangle law of vector addition, right? What does it say? Triangle law of vector addition says that first two sides represents the, right? If first two sides represents the vector, the resultant will be represented by the hypotenuse of the triangle, right? So according to that, this FR will be equal to, right, magnitude will be equal for F2 and direction of FR is minus of F2. So the resultant will be, so FR plus F2 will be equal to 0, right? So FR plus F2 is 0. That means V will be constant. Right? We will be constant. So remaining unchanged is the answer. See, this is basically they have given this question, right, in force, but it is on the vector, right? So force as a vector. Here they have used this concept for the force as a vector, right? Hope you understood this, right? So here we did this question which was asked in AI EEE 2003, very long back, but yeah, see how they are using this. Right. So concept, we have to focus on the concept, right? Hope you understood this, right? So we'll talk more on the forces, right? In the coming videos, we'll talk more on the forces. We'll see the questions, right? How they're asking, what will be the normal force and all. So be with us. We'll meet in the next video. Thank you. Have a nice time. Okay. Thank you. Bye.